All right, welcome back to BSE 308 Engineering Ethics, part number 3, a case study. This will be the last of our modules, and I am going to ask you to do something at the end of this a little bit different on your session summary sheet. I'm going to have you go ahead and fill that out as you normally would. You can be a little bit more brief, but I want you to answer some questions or a question. I've got a little assignment that goes along with this particular case study. I'd like for you to meet our young engineer, Emily. Emily is a UW engineering graduate, and she works as a design engineer for a medium-sized manufacturing company called Biosustainability Engineering, which I am going to call BE. So Emily's not been out of school for too long. This is her engineering manager. Her engineering manager is Aaron, and he's a few years older. He also graduated from UW-Madison. And Aaron's degree was in operations and technology management. Aaron is also close friends with a young woman who he went to school with, also a UW graduate, who was in the same program as Aaron. Deanna's company is called DS Control Systems, or DSCS is what I'll call it. And they compete with Aaron and Emily's company, BE, on a few products, but they also work together on some projects. Because they have this kind of collaborative relationship, Aaron and Deanna meet about once a month for breakfast. And at one of their breakfast meetings, Aaron asks after the meeting is over with to meet with Emily. He's pretty excited. She learns that DSCS has developed and patented an exciting new process control system, but DSCS doesn't have the manufacturing capability to actually make the product. So Deanna and her company, DSCS, they want to pay BE, Emily and Aaron's company, almost $3 million to manufacture the first 2,500 units. BE will also get 10% of each sale. So this is kind of like a really lucrative opportunity. Each control system sells on the marketplace, retail, for about $10,000. So the total production, when all 2,500 units get sold, is about $25 million. For BE, for Emily and Aaron's company, this means $3 million to do the manufacturing and all the final engineering work. They need to do a little bit of engineering work just to kind of tweak it and make things work in BE's manufacturing facility. And then they're going to get another 2.5 million. Remember, they're going to get that 10% commission. So they'll get another 2.5 million in total commissions as this project gets sold. DSCS has orders for nearly 800 of these systems from companies all over the world. It looks like there's a growing demand. The promised delivery date, though, is later this year. So they've got some time pressure. They've got 800 of these effectively sold, and they've got some money coming in. Deanna told Aaron that she and her technical staff had traveled to another country. This is actually pretty common. And they had a bid from another manufacturer in another country to do the same manufacturing and assembly work in a factory for a third of the cost, but Deanna was not confident that the job would be well managed and that the final product would be built to the quality standards that Deanna and her company expected. In the conversation with Emily, so we're back to BE now. So Aaron talks to Emily and says, this is going to be great for BE. And I want you, Emily, to run this project for us. Deanna knows that the product still needs some engineering, some tweaking on the engineering side. And I've told her that you are the person to make that happen. Aaron also tells Emily that once the first 800 units get sold and they get the money for it, that she will be paid an extra $30,000 as a bonus. So Emily, you can guess, Emily's pretty excited. So she's super excited. They agree that DSCS will share all of the design documentation, the files, the data, the drawings, all the materials, so that Emily can do her initial engineering review. And they're going to do that as soon as they get the $3 million contract signed with her boss, with Aaron. Emily estimates that it's going to take her and one of her staff, they're going to work really closely together. His name is Devon, about 2 weeks to fully understand the next steps before they gear up their manufacturing facility. That's going to take a few months, actually. And there's a meeting between Emily and the DSCS technicians scheduled after the 2-week review is complete so that Emily can ask lots of questions, clarify, and get additional needed information. Emily, though, is kind of surprised to find out that there are no engineering graduates who are actually designing or involved in the design process at DSCS, even though they seem to make pretty good products. She's concerned. On a Saturday morning, Emily receives a secure link and a VPN login and password that allows her and her coworker, Devon, to begin their review. They spend most of the weekend. They're looking at drawings, calculations, all the documentation. But on Monday morning, Emily and Devon make a pretty disturbing discovery. The product that they are being asked to manufacture is not compliant with a whole bunch of several critical engineering, design, and safety standards, and several of the assumptions and calculations that were done are not done correctly. In fact, 2 of the calculations that predict the output of this finished product overestimate the system performance probably by a factor of 5. Emily also calculates that the heat buildup in the system is going to be great enough to melt the components that are in this manufactured system and possibly start a fire or worse. Devon reminds her that this is going to be an even bigger hazard when people see that the system is underperforming and they attempt to make power adjustments to increase the output. Further, Emily is aware that some of the specified materials are not compatible with each other and with many of the products that are going to flow through this process control system. So what I would like for you to do, this is like a really a fairly realistic example of the kind of thing that can happen when 2 companies are working together, and that when young talented engineers are asked to jump in to a project or into a process or a flow of work for which they may or may not be prepared, or for which they may or may not have been involved in a lot of those designs, a lot of those decisions. So what I would like for you to do, please, is to review that NSPE Code of Ethics, the canons and details. I would like for you to write a paragraph. And the way I'd like for you to think about this is to write a narrative or a script. So think about yourself writing it for a TV show or a movie of what a conversation might look like between Emily and Aaron. And I want you to use one or more of the elements from that code of ethics. And I want you to tell me what are at least a couple of the possible outcomes that could occur as a result of this conversation. Put that in your session summary sheet. I hope that this has been helpful. I hope it exposes you to the breadth of some of the engineering ethics, things that are out there, gives you some tools, some resources, some ways to pass that part of your FE exam. You'll pass it with flying colors. And again, look forward to reading your responses for the Emily, Aaron, and Deanna and Devon case when I get your session summary sheet. I'll talk to you soon. Take care.